Evaluating logarithmic functions. Write the following equation in equivalent exponential form. Here we have a logarithmic equation. In order to convert it to exponential form, we need to identify the base, the exponent, and the answer of our exponential form. So the base is the small value written beneath the log. So this is our base. Then the 25 in this case is our answer to our exponent problem. And then the 2 is our exponent. So when we write this in exponential form, we have the base, which is b, exponent, which is 2, and that equals an answer of 25. So this is the equivalent exponential form. Write the equation in its equivalent logarithmic form. Now we're going backwards. 625 represents the answer, 5 is the base, and 4 is the exponent. So when we write our log form of the answer, I have the log of the base, so that would be 5, and it's 625 is the answer, so that goes here, and that equals the exponent, which is 4. So this is the logarithmic equivalent. Evaluate the expression without using a calculator. The first thing I'm going to do is set this equal to x because I want to solve this logarithmic expression. Now I'm going to change the logarithmic expression to exponential form. My base is 2, my exponent is x, and that equals 128. Now I'm going to ask myself, 2 times what power gives me 128? Well, we can go ahead and create a quick chart of 2 to certain powers. So I know 2 to the second power is 4, 2 to the third power is 8, 2 to the fourth power is 16, and as you can see, I'm just taking the previous number and multiplying it by 2 to get my next number. So 2 to the 5 is 32, 2 to the 6th power is 64, and 2 to the 7th power is 128. So since 2 to the 7th power equals 128, that means that x must equal 7. Evaluate the expression without using a calculator. So we're going to do the same thing. We're going to set this equal to x and then rewrite this as an exponential function. So I have my base, which is 11. I have an exponent of x, and that equals the 1 over 11. Now, 1 over 11 is usually going to be a negative exponent. Because remember, whenever we raise something to the negative 1 exponent, we have 1 over that number. So since 11 raised to the negative 1 exponent is 1 over 11, I know that x must equal negative 1. Evaluate the expression without using a calculator. Log base 6 of 1. Here we're going to use the general property of logarithms. And that tells me that log of any base to 1 always equals 0. So I know that log base 6 of 1 is going to equal 0, and that's my answer. Evaluate the following expression without using a calculator. 8 raised to the log base 8 of 4. Here I'm going to use the inverse property. That property tells me that whenever I have a base and it's being raised to the log with the same base, then my answer is the number in the log, or the number that I'm taking the log of. So in this case, we have a base of 8, and the log also has a base of 8. So our answer is what I'm taking the log of, which is 4. So my answer is 4.